Hello everyone and welcome to this Derive tutorial. In this tutorial I will be talking about optimization. When you create a texture with Derive, you can assign up to 5 maps containing information that are necessary for rendering. And the question is whether you always need all 5 or whether you can do it in a different way. For this I have opened the a mud sample. It's an example project that comes with Derive, and with this example I'm going to show you how or ways to optimize things. So first, as you can see, this is our rendered preview. This is what our texture looks like. It's mud with a bit of green on it and partly glossy and so on. And if we have a look at the master now, we can see that all of the 5 ports are connected. So we have an albedo, we have a normal map, we have an ambient occlusion map, we have a height map, and we have a specular map. And first, in order to optimize things, we have to look at a couple of things first. So every texture can hold data in up to 4 color channels, right? And those color channels are red, green, blue, and alpha. Now let's have a look at which textures store which data in which channels. In another tutorial I talked about specularity and that it can vary where which data is stored, but in this video we're not going to talk about that. So in this video the specular map is going to contain data in all of its 4 channels, the specular color in red, green, and blue, and the specularity information in the alpha channel. But let's talk a bit about the other 4 maps. We have the albedo, which contains basically just a diffuse surface color, and it means that the albedo only holds data in the red, green, and blue channel. And the normal map does the same thing. It holds data for the normals in the red, green, and blue channel, and both the albedo and the normal map hold no data in the alpha channel. Okay, now why is that important? We'll learn that in just a minute. Let's go to the height map and see what the height map is composed of. So the height map contains height information. But height information is no color information, so it doesn't need red, green, and blue to describe the data that it provides. It only needs one of these channels because it's only a float data. There's just one height for every pixel, right? So the problem is that usually when you work with different shaders and you haven't built them yourselves, you're just using them, you always have the problem that you don't really know which channel the data is read from, right? So that means that whenever you get a texture somewhere that comes with a height map and an ambient occlusion map, usually the data for the height and the ambient occlusion map is stored in all 4 channels. And since it's stored in all 4 channels, whatever channel the shader that will render the ambient occlusion, for instance, picks that data from, it will find it. But if you say had it only in one channel, like in the red channel, and the shader that you're using happens to grab it from the blue channel, then it won't find any data there and you wouldn't see neither height nor ambient occlusion. So just to be safe that the data will be used by a shader, it's stored in all 4 channels. Now, the obvious downside of this is that it's very inefficient and you're creating large files with data that is not actually even required. If you knew which channel the data is being grabbed from, you could store it in only one channel, in a channel of your choice, and you'd be fine. Now, let's get back to our albedo and our normal map. We know that our height map and our ambient occlusion map have the same data stored in all 4 of their channels, while the albedo and the normal map only have data in their red, green, and blue channel, but both of them have the alpha channel free, right? So we can store data in there. Now, the idea is to take the height information and store it in the albedo's alpha channel, and take the ambient occlusion data and store it in the normal map's alpha channel. And if we do that, and it works, we can work with 3 textures instead of 5, which would mean we can save up to 40% in file size and then later memory usage and data load. Now, to do that, we will need a custom shader. I will not write a custom shader as we do this tutorial. I've already written one, but I'm going to show you how to optimize the texture output so you can use it with a custom shader, and then I'm going to show you how it looks in Unity. All right, so here I am in the mud project, and here we can see that the height map and the ambient occlusion map, they still connect to the ports on the master node, and to put them in the alpha channels of the normal map and the albedo, we have to first, let me just quickly create a bit more room for myself here. Maybe collapse that. Okay. And first off, what we need to do, let's disconnect these 4. As said, the specular map will stay just as it is. We won't do anything with that. But for the albedo, I'm gonna add an append node. Whoops. Okay, of course. First, I need to break up the channels so we can access each channel individually. Now, I have an append node that creates an RGBA output that I can compose myself. So I will say the red, green, and blue from the albedo are going to be in the RGB channels, and the height map is going to be in the alpha channel. Whoops, it's a texture, so I still have to turn it into a float value, but that's no problem. Here we go. Right, now our color information is in the RGB channel, and the height map or the height data is in the alpha channel. And I'm just going to plug that into the albedo input. And we're going to do the same with the normal map. Let me just quickly get this out of the way. And the normal map is also going to get a channel breakup and an append node. Right, and we're going to connect the RGB of the normal map here and the ambient occlusion into the alpha channel, and we're going to put this into the normal map input, right? So now we don't have a displacement map or a height map, and we don't have an ambient occlusion map, but we still have the data. We have them stored in the normal map and in the albedo. So now if we export, we only need 3 textures, but we have all the data that we need. Now let's have a look at the preview. Not much has changed at first glance, but we see that tessellation and displacement are both high, but we see no displacement at all. So this is basically its flat surface right now. And the ambient occlusion, we can change that and it will do nothing. So basically displacement and ambient occlusion are both missing. Right, so we know that these are not there, so let's go ahead and export our textures, and I'm going to export them right into the assets folder. Name it, well, the name can stay the same. Just make sure, since we have stored data in the alpha channel of each texture that is being outputted, to select a file type that has an alpha channel. If you select JPEG or bitmap, those don't have an alpha channel, so that data will be lost. Don't do that if you have anything in the alpha channel. So I'm just quickly going to export, and this may take some time, depending on how fast your machine is. It can take more or less time. And yeah, usually on my machine it takes a project that is larger at that resolution, 2048 by 2048, usually doesn't take longer than let's say 5 to 10 seconds, and I think it's done. So I'm just going to close that now. And I already have a plane here, and I have a directional light and a reflection probe to have pretty much the same light setup as in the preview. And here I have a custom shader that I made, and it's called DD Tessellation Optimized. It's basically the same as the tessellation shader from the preview. And we also see that Derive has created a folder called Mod Complex, which is the name of the project. And here we have our 3 maps, and we have the sample materials, and I'm just going to simply grab the Mod Complex tessellated and drop it on that plane. And we see that we're still missing the displacement and the ambient occlusion. So let me just quickly go to the material settings, and instead of the tessellation shader, I'm going to select the tessellation optimized, right? And now we have the albedo with the height map in the alpha channel and the normal map with the ambient occlusion in the alpha channel, and we can see that we now do have, I don't know if you can see it, but I think you should be able to see it. We do have displacement, and we also have ambient occlusion. Okay, so now we have the data that we would usually or normally store in 5 textures. Now we have it in 3 textures, and we have saved a lot of memory and disk space. And that is it for this tutorial. I hope it was helpful, and if you need any support, just drop a message on the forum or send me an email. And yeah, don't forget to check out our other tutorials, and see you in the next video. Bye bye.